Hey guys, it's Jonas here, and in today's video I want to talk to you about pressure altitude. Now this is something that a lot of students have approached me and asked me to do a video on this. It seems like you guys are struggling a little bit with understanding pressure altitude, also density altitude, but I'll dedicate this video to explain just pressure altitude, and then in the next video we can build upon that, and then I'll do one on density altitude. Now pressure altitude when it comes to the exams is really crucial, guys. I'm sure you guys would know that throughout your PPL and CPL and ATP subjects, like 70% or 80% of the subjects you can get questions on pressure altitude and on density altitude. Okay, so this is something that's really heavy when it comes to your exams and marks in the exams as well, because typically these questions are 4 marks each, right? So if you can understand this and get this right all the time, then Bob's your uncle. Then it's going to be quick and easy marks for you. Okay, so I've got the lesson plan on the left hand side of the board here. So the first thing I'm going to talk about is just the exams and marks. So we'll just touch on how this is fitting in with the picture when it comes to exams and marks in the exams as well. I've already touched on it just now, but I'll quickly talk about that. And then it's crucially important, that we talk about the basics, because I've found that a lot of the students don't understand the basic principles behind pressure and temperature and density of air. And they can work pressure altitude out and they can work density altitude out because they just follow the formula. But when it comes to being able to explain to me what that figure means that they got to, they really struggle. And that's not really where we want to be, right? That destroys the whole purpose of getting to that figure, because that figure must tell you something. You must actually understand what that figure means and how to use it in your flying and what will happen with the aeroplane in terms of performance when you look at the different figures. So it's really important that you understand the basic principles involved. So we'll just talk about pressure and temperature and the effect that different pressures and temperatures has on air density, because that is what it all comes down to, right? It comes down to the effect on density. And then we'll quickly talk about ISA as well. This is crucially important as well. You'll see you'll get a lot of questions on ISA typically, throughout all your exams most probably. Principles of flight, meteorology, flight planning, navigation, ATG. So there's a lot of different subjects that's actually or different exams that's actually asking ISA conditions and where you need to work with the ISA conditions. So I'll just touch on that. That is really important. International standard atmosphere. And then we'll talk about pressure altitude, and I'll give you my explanation and my definition of what I understand as pressure altitude. It's really not a difficult concept, guys. It's honestly so straightforward. You just need to get your mind around it, and as soon as you've grasped it, you can't forget it, honestly. If you understand what pressure altitude is and how easy it actually is to use it and do the calculations, and how it affects the performance of the aeroplane, then Bob's your uncle. That's 3 marks for you in the exam right there, okay, given to you. Right, so I'll tell you guys my personal definition of pressure altitude, because I found that a lot of the notes, make it really difficult, right? Sometimes even I read a definition in certain notes on pressure altitude and then I don't understand what the notes are saying. So it's really unnecessary to have it that complicated. It's actually just very straightforward and easy. Then we'll do a few calculations. I'm going to take you guys through 3 calculations so that we cover all the different variables that you can get in the exam. That's obviously really important. I'll actually do 2 on the board and then I'll just talk about 1, right? So the standard one, the one that's not so difficult, I'll just talk about quickly. So we'll do that. I'll give you guys 3 calculations. And then the most important part, and this is what I mentioned earlier as well, is to quickly look at the overview and understand what that figure means. So if you got a pressure altitude of 3,000 foot, what does it mean? How do you apply it in your flying? What will happen with the aeroplane? How does it affect the performance? Things like that. Because like I've said to you, I get a lot of students, they can work out pressure altitude perfectly, and you ask them in a PPL test or in an oral exam, so explain to me how would this affect the aeroplane performance, and how would you think as a pilot when you have a certain pressure altitude or a certain density altitude. And I think that is where a lot of the students are, are lacking the knowledge. They don't understand what they've just calculated. And you need to understand so that you can apply it in your flying, okay? So you can be, a rocket scientist and do all these calculations and everything, but at the end of the day, the most important thing is actually going to be to understand what you've just worked out and to be able to think and make decisions based on that figure that you've calculated, right? That's at the end of the day why we need to do these things. So before I start with everything, I think what happens in the aviation industry these days is, we really tend to forget that when you get issued that brown book, or when you get issued the blue book, or for helicopter I know it's different colors, and but when you get your flying license, guys, the civil aviation authorities and the instructor that has signed you out has given you the permission to take people's lives in your hands, okay? And I want to make one thing clear. It is your responsibility as a pilot in command to make sure that you are up to standard with your knowledge, that you are up to standard with calculations, that you know your aeroplane, that you understand weather systems and these type of things, okay? I get a lot of students, they're doing all sorts of questions and practicing questions and doing this and doing that, and they become really clever, by passing the exams or finding a way to, to pass the exam. And then I start asking them questions that is not just a yes, no answer, where they actually have to explain things, and then they struggle, okay? And it's your responsibility as a pilot to make sure you understand these things, guys. And there's lots of instructors and lots of flight schools and, notes and the internet, everything is there to make sure you build up your knowledge. So don't be the pilot, that is just getting in the airplane, just loading passengers and just going. You're playing with people's lives at the end of the day, right? You need to take that responsibility to make sure you're knowledgeable and to make sure you understand, things like this. Okay, so that's what I want to start the video off with, is just to make sure that we're on the same page. I like to set high expectations and high bars and high goals, and you must aim for getting it. And once you've got them, then you aim higher again. Okay, there's nothing as good as a well-trained and knowledgeable pilot, and it's your own responsibility to make sure you are knowledgeable. By all means, we are there to guide you, but you need to put in the effort. You need to take the action. We can take you to the water, but we can't make you drink, right? So when I'm done explaining this, I would really like you to comment below the video. If you like the video, please like the video if you've liked it, if it's worked for you, and if you understand what I've explained. And follow my YouTube channel. Follow our group, our student group on Facebook, ExamRevolution Community. We really motivate each other. We post, students' success results in the exams. So, when someone has passed an exam, we really celebrate, and we keep on motivating each other, because this is what the industry is about, right? And I think we're lacking that. So we really need to keep each other motivated and help each other, guys, okay? So follow us on Facebook, ExamRevolution Community. Like this video, comment below this video if this has worked for you, and if there's something else that you're struggling with and you would like me to explain, or that you would like me to make a video about, okay? Right, so let's start. So the first thing is exam and marks. I've already touched on this. I said to you, pressure altitude calculations, and density altitude calculations is typically 4 marks in the exams, right? So if you get a theory question, typically that's 1 mark. Guys, you can have 4 of those questions wrong and have 1 of these questions right, okay? And then you've balanced it out. So if you get this question wrong, you need to make up with 4 theory questions to actually, not fail, if you understand what I mean. So this really weighs heavily in the exam. It's 4 marks for each of the questions. So if you get 3 of these questions, you get all 3 wrong, that's 12 marks gone out the window, okay? And honestly, this is really easy marks, okay? So give me your attention here. Make sure you understand what we're talking about. And like I've said as well, guys, this is, you find this in a lot of your subjects, right? And in a lot of your exams. Principles of flight, definitely. ATG, I would say 90%. Meteorology, definitely. Flight planning, most definitely. Navigation, most definitely. Right? So you can see how it all, the one where you won't find is most probably aerial and human performance. Okay? And all the others you'll most probably find it. And same goes for CPL and ATP. Okay? So this is important, is to keep in mind that this, really weighs heavy in the exam. So let's talk about the basics. Before I am going to go into calculations and those things, let's make sure you understand what the effect of pressure and temperature is on air density. Okay? Because if you don't understand this, then you're not going to understand, the effect of pressure altitude or the effect of density altitude. So I'm going to start off by looking at pressure, and I'm going to try and keep this really, as simple and straightforward as possible. Right? So let's imagine that's a block of air. So we have our different air molecules over here. Okay? And you standing over here. Okay? And you've got a barometer in your hand. Let's just draw it like that. Okay? A barometer is the instrument that is measuring air pressure. Okay? Now what a barometer does is, a barometer is actually just measuring the weight that the air molecules is exerting on the instrument, right, on the barometer. So each of these air molecules, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. Let's put 10 in here. We've got 10 air molecules, and each of these air molecules actually have a specific weight, right? And because of gravity, we have gravity, right? That's why if I drop this pencil, then it's falling down towards the ground. The same happens with air molecules, guys. Air molecules are surrounding us and surrounding Earth and the atmosphere, and Earth is actually attracting these air molecules towards the Earth's surface, right? And that's why as the Earth is attracting these air molecules, they're weighing down on the Earth's surface, and therefore we can measure the pressure that the air molecules is weighing down onto the Earth's surface. Okay, and that is what we call air pressure. Now obviously the more air molecules you have, the heavier it's going to weigh down, right? And the less air molecules you have, the less the pressure is going to be on the Earth's surface. Okay, that's a really important concept to understand. So if you're standing here, now you've got 10 air molecules that is weighing down on the barometer that you're holding in your hand. Okay, so let's say the weight of this block of air when you're standing here, okay, is, let's call it 1,000 hectopascals. That is the weight of this block of air. Now, what you need to understand is this is obviously just, the weight of air is finite, right? It doesn't just, go up forever. The weight of air is finite. You get to a point where gravity is not taking its toll on the air molecules anymore, and it's not pulling it towards the Earth. So air molecules are just, moving around freely in outer space where there's no more gravity. So we use this block of air. This is the block of air that's weighing down. Okay. So this is 1,000 hectopascals. That is what this block of air is weighing. We measure it with a barometer. Now let's imagine we can teleport, right? So we can go up, we can go and put ourselves on, this was sea level. Let's go and put ourselves at 10,000 foot. Okay. Now, when we were at sea level, this was sea level, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 air molecules weighing down on the barometer. Okay, and that gave us a pressure of 1,000 hectopascals. So it's like 100 each, for instance. Now we've gone up to 10,000 foot. So we've effectively lost all these air molecules. Okay, the weight of those air molecules are below us. We don't feel that. If we go and stand here on this line, okay, and we now want to measure what the pressure of the air is, we're only going to feel these molecules. 1, 2, 3, 4, 5. So we've basically halved the amount of air molecules by going up 10,000 foot. Okay, so if we take a barometer and we measure what this block of air is weighing, okay, we most probably going to see something like 500 hectopascals. Now, these are just theoretical numbers. Please don't quote me on this. It's just for explanation purposes. Okay, so clearly you can see we've got less air molecules. And guys, this is exactly why air pressure is reducing as we go higher. You've just got less and less air molecules that is weighing down on a barometer. Okay, so if you could take this whole block of air, measuring it here at the bottom, it's going to be heavier, right? If you start going up and you've just got this little block of air over here that is weighing, so you're sitting on 10,000 foot, then you've just got this little block of air, that's just 5 air molecules. So obviously the weight of the air block is going to be less, and therefore the pressure that it's exerting is going to be less, right? So therefore pressure reduces as we go higher. Now what happens with pressure, I just want to get rid of this. What happens with, not with pressure, what happens with density as pressure reduces, okay? So we've now established that, okay, we know that this whole block is weighing 1,000 hectopascals, okay? And at 10,000 foot, it was weighing 500 hectopascals, right? So if the pressure is reducing as we go higher, what happens with the density of the air? Now this is actually a very straightforward and logic concept if you think about it carefully. You've got air molecules in this block of air, right? Now if you can imagine all these air molecules pushing down onto the Earth's surface, where would they be compacted and more dense? It's here at the bottom, right? So the air molecules would be really close to each other over here, right? And as we increase altitude and the pressure becomes less and less and less and less, what happens? The air molecules start moving further away from each other because there's not so much pressure that is compressing them together, guys. Okay? So here in this block, we have a lot of weight hanging down, so it's compressing those air molecules. As we're going higher, the pressure starts reducing and air molecules are actually moving further away from each other, right? And therefore, if I now take this block, for instance, you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 air molecules just in this block of air. If I take this same block of air and I put it, let's put it here, I've just got 3 air molecules, okay? So for the same volume, here I have 11 molecules, and the same volume of block, or the same volume and block of air over here has just got 3 air molecules. So you can see the air molecules are much further away from each other, and also there are not as many air molecules in that block as what it is over here. So you can see as you increase altitude, the density of the air becomes less. So as a matter of fact, what it would look like is actually something like this. So it will be tightly packed over here, really dense, and as you go higher, it would start spreading. Yeah, something like this, right? So you can see as you increase altitude, the air molecules start moving further away from each other, right? They start expanding. And so the density of the air over here is very low, and the density of the air over here at sea level is very high, okay? So that is how pressure is affecting density of air. Now if I can ask you, where would you want to be flying? Obviously you want to be flying here at sea level, right? You want to be, let me take red. You want to be flying over here because a lot of air molecules means there's a lot of air going through the engine, so we can add more fuel, means better performance, more thrust, and also more air molecules over the aircraft's wings, right? So if we have more air molecules over the aircraft's wings, it means more lift, so we get better performance. As we go up to 10,000 foot, things start changing, right? Not so many air molecules anymore, not so much lift anymore, not so much thrust anymore. So you can clearly see it reduces aircraft performance, okay? So this is what's happening with the pressure of air. This is the basic concepts of air pressure. So to recap quickly, sea level, high density because the pressure is high. As we increase altitude, pressure starts reducing, and therefore the density of the air starts reducing because the air molecules can move further away from each other because the pressure is not so high anymore. Okay, so pressure and density goes hand in hand. If the pressure increases, the density increases. If the pressure starts reducing as we go higher, then the density starts reducing. The air molecules start moving further away from each other. Okay, this is an important concept to understand. Really, really important, crucial. If you don't understand that, then you're going to struggle with pressure altitude calculations. Okay, so the next thing I want to talk about is temperature. Now, we've now seen what the effect of pressure is on density, right? If we increase pressure, density increases. If we decrease pressure, density reduces or decreases. Okay, so it goes hand in hand. What the one does, the other one will do. Temperature is actually the opposite. Okay, so imagine a block of air over here. And imagine air molecules here. This is a really cold block of air. Okay. Now, I'm just quickly going to talk about temperature because we're not doing density altitude, we're doing pressure altitude. So I don't want to be spending too much time on that. But what happens, guys, is if you take a look at temperature, if you heat up air, so let's say, we get insolation from the sun during the day, so the land surface heats up, okay? What happens if the Earth's surface is heating up? Obviously, the air that is in contact with the Earth's surface is getting hot as well. And I'm sure all of you know that hot air rises, okay? And as hot air is rising, so I'm going to draw another block here. As hot air is rising, so it's rising, okay? the air molecules start moving further and further away from each other, right? So it's almost that same effect that you have. Okay, so the air molecules are rising because they're getting hotter, and they start moving really far away from each other. Okay, so this is what happens with hot air. The air is rising. The pressure is obviously, this is a low pressure that you'll find over here because of air rising. It's like a suction, the same as a wing works, right? So it's a low pressure over here. And in cold air, the opposite happens. So in cold air, your air molecules would actually sink down and they would start compressing over here. So cold air is more dense because the air molecules wants to sink down, they start compressing. So that means that the density of the air would actually increase. Okay, this is vitally important to understand when we're doing density altitude calculations. So to recap, you can see an increase in temperature decreases the density, right? If we increase the temperature, we make the air hotter. The density is decreasing because the air molecules moving further away from each other. If we decrease the temperature of the earth, the air, then the air molecules would start sinking down and start compressing as they move down towards the ground. Okay, so this is an important concept to understand, but we'll talk about this in more detail when we do density altitude calculations. Okay, that's really where temperature comes in, and it plays a very big role in the density of the air and our calculations, and also the performance of the aeroplane. So the next thing I quickly want to talk about, guys, is ISA. ISA stands for International Standard Atmosphere. Okay, now if you don't know what ISA is just a, let's call it a fairy tale or an ideal set of conditions that ICAO, the International Civil Aviation Organization, they've come up with this set of conditions because, I mean, you can imagine if you were going to test an aeroplane today, right? You're doing a test flight with a new aeroplane today. Today might be 30 degrees Celsius, and I mean, the wind might be pumping and the pressure might be 1,030 hectopascals, right? So really high pressure. Then tomorrow comes, the pressure has dropped suddenly to just 1,000 hectopascals. It's really cold outside, like 10 degrees Celsius, and there's no wind. Now, if you're testing an aeroplane on the 30 degrees Celsius day, where the pressure is also high, and you're testing it on a cold day where the pressure is low, then, you know, the performance of the aeroplane would not be able to be compared on those 2 days because it's completely different, you know, sets of conditions. Okay, so we need a certain reference or a certain datum that we can work from when we are trying to establish what the performance of the aeroplane is going to be like. Okay, so the important thing here is to remember what the ISA conditions are. Okay, and you're going to get asked this in MET, in flight planning, in NAV, most probably in ATG as well. Okay, so guys, you really need to spend some time on remembering these, and I used to just write them all over. Okay, so I had them, you know, sticky notes everywhere, and I was, you know, telling people, hey, did you know that ISA is 15 degrees Celsius at sea level? And I was really living it, right? That's the only way I could remember it. So ISA conditions is really important for the exams, and ISA conditions are the following. It states that at sea level you have the following conditions: 15 degrees Celsius, let me do that, 15 degrees Celsius at sea level. Okay, this is the ideal condition for temperature, and it says that the pressure at sea level is 1013.25 hectopascals or 29.92 inches of mercury. Okay, now in South Africa we work with hectopascals, in the States they work with mercury, right? Our altimeters is calibrated according to hectopascals. In the States you fly with inches of mercury. Okay, so this is the standard pressure that, you know, ISA is stating it should be at sea level. Now obviously it's not, you don't always have 15 degrees Celsius at sea level, you don't always have this pressure at sea level, right? But this is just the ideal set of conditions. So when we have different conditions, we compare the conditions we have to these conditions, and by doing that we can get an idea of what the aeroplane is going to do. That is what we're actually doing when we're calculating pressure altitude. That's all we're doing. We're comparing our set of conditions to the ISA set of conditions. Okay, then ISA also says that the temperature of air reduces at 1.98 degrees Celsius for every 1,000 foot increase in altitude. Now for PPI level you can just go 2 degrees Celsius for every 1,000 foot, you can just round it up. So 1.98 degrees Celsius for every 1,000 foot for CPL and ATPL level, and for PPL level 2 degrees Celsius for every 1,000 foot. Okay, we'll work with this when we do density altitude calculations. For pressure, this is not so important. And then it also says that air is dry and uniform throughout, okay, which means that there's no humidity in the air, no water vapor in the air is just dry and uniform, meaning it's the same throughout, okay. That'll be a video for another day as well, where I'll discuss, humidity, water vapor effects on aeroplane performance when it comes to humidity. Okay, so those are the set of ISO conditions. Crucially important to remember, guys, especially for the exams and doing pressure altitude and density altitude calculations. Okay, so make sure you guys have this. Then another thing, you need to be able to go in between these as well, meaning they might give you in the exam, they might give you inches of mercury, okay, and you need to be able to convert that into hectopascal, or they'll give you hectopascal and you need to be able to convert it into inches of mercury. Now it's very easy. I mean, if you just go 1013.25, oh, I forgot to tell you as well that for PPL, don't worry about the 0.25 for pressure altitude calculations, okay? For CPL, ATP, use the decimals. For PPL, you can just use 1013. But anyway, so 1013.25, divide that by 29.92. I can actually do it right now. 1013.25 divided by 29.92 gives you 33.865. 33.865, yeah, hectopascal for every 1 inch of mercury. Okay, so you can see it's easy. If you know how many inches of mercury you have, you just times that by 33.865, right? And the same goes for when you want to go from hectopascals to inches of mercury, you just divide it by 33.865. Okay, this is crucially important for the exam, guys. Always, when you do pressure altitude, density altitude calculations, you must work with feet, not meters, feet and hectopascal, okay, not inches of mercury. Okay, so that was ISA. Let's get going with our calculations. Now, the first thing I need to talk about is the definition of pressure altitude. Now, this is where a lot of people get confused, and it's actually really straightforward. Okay, so pressure altitude, my personal definition of pressure altitude is, it is the altitude of the aerodrome or the altitude of the aeroplane above the 1013 pressure line. That's all. That's all it is. You need to determine what is your height or altitude above the 1013 pressure line. Okay, so if you can imagine, if Earth was here, okay, let's say the 1013 pressure line is like that, and you're flying over here, then you can either be flying on altitude, which would be from sea level, right? Okay, you would have Q and H set on your altimeter, or you can be flying on flight level, which is actually the same thing as pressure altitude, and that is from the 1013.25 pressure line. Okay, it's as easy as that. So sometimes what they'll do is, they'll give you the Q and H, so they'll give you what the pressure is over here at sea, and they want you to tell them how high you are above this 1013 pressure line. That's all they want. That's all they want when they give you pressure altitude, guys. Okay, so it's actually really straightforward, right? And people make it very complicated, but it's actually not. So I'm going to show you guys how to draw a picture and how to just calculate this really quickly. Now, it's very easy if you're in the aeroplane. How can you get pressure altitude? You just put 1013 in the subscale of the altimeter, and whatever altitude is showing there, that is your pressure altitude. Because what you're doing, if you're setting 1013.25 in the subscale of your altimeter, you are telling the altimeter, read my altitude or my height above this line. Then it will automatically read that. And if you put Q and H in the subscale, so the pressure at sea level, you need to know this, right? You need to know what Q and H is. That's pressure at sea level. So if you put Q and H, let's say Q and H is 1030. If you put Q and H in the subscale of the altimeter, it will read you your height above sea level, okay, for that pressure. So that is pressure altitude, right? So let me show you how to calculate. Obviously, I mean, we can't always run to the aeroplane, right? We can't always run to the aeroplane and go and jump in the aeroplane and, set 1013 on the altimeter to get the pressure altitude. We need to be able to calculate this, okay? And guys, this is really important. And I've talked about this earlier. When I said you get given the responsibility and lies in your hands. It's important to understand what effect this has and what effect density altitude has on the aeroplane's performance, okay? So make sure you understand how to use this and how to work it out, okay? So let's do a calculation. Now you're going to get given two things in the exam. You must be given the elevation, okay, or then if you want to call it the height of the aircraft, so either the elevation of the aerodrome or the height of the aircraft, and then they must also give you the QNH. You must get the sea level pressure. So the question would be aerodrome elevation, I'm just going to write elevation, is 2,500 foot. QNH 1030 hectopascals, and then they would ask you what is the pressure altitude. Okay, easy as that. The first thing you need to do, guys, is you need to draw a picture. Okay, and I've had so many students that's come to me and say no, they don't have time to draw a picture, or they're trying to be clever and just punch the numbers into the calculator, and you know what happens? They walk out of the exam crying or being frustrated or irritated. And then I ask them, did you draw pictures? Because I see their coaching report and I see its pressure, altitude, density, altitude calculations, and they didn't draw the picture. So if you don't want to be drawing the picture, don't even continue watching this video. If you're willing to draw the picture and spend 30 seconds on making sure you get 4 marks in the exam, continue watching the video. Okay? So draw a picture. That's the first thing. And it's as easy as this. You just draw Z. Okay? Just like this. It's a strange Z, I know, but it works, right? So I like to draw in a little control tower as well, just to make it, a little bit creative. Good for the creative brain. Then what you want to do now is, so the first thing is you draw a picture. Now you've drawn the aerodrome over here. Okay, it can be an aeroplane as well, guys. You can put the aeroplane there as well, doesn't matter. This is important because eventually this is showing that you are above sea level, right? So here's sea level, and this is showing your aerodrome or aeroplane is above sea level. And the second thing we do, so number 1, write this down, is draw a picture. Draw this basic picture, just the structure, the skeleton. Number 2, use the information you have. So information is 2,500 foot and 1030 hectopascals. Here's 2,500 foot because this is our elevation. This is how high we are above sea level. Okay, so we are 2,500 foot above sea level. And what is the pressure at sea level? This is our QNH. It's 1030 hectopascals. That was number 2. Number 3, write it down in capital letters. It's think. Okay, one word, think. Now you need to go and think what they're asking you. They're asking us to determine the pressure altitude. So what is pressure altitude? It is the altitude of the aeroplane or of the aerodrome, depending on what they ask, doesn't matter, above the 1013 line. Now guys, if my sea level pressure is 1030, a pressure of 1013, will it be higher or lower? If you said it's going to be lower, you're wrong. Okay, it's going to be higher. And the reason for that is, remember, as we increase altitude, our pressure reduces, right? So we'll go 1030, then 1029, 1028, 1027, etc., as we go up. Okay, so the 1013 pressure line will be lying somewhere over here. And draw it in and write there 1013. Okay, this is really important to do that. And if you get this step wrong, guys, your whole calculation is going to be wrong. If you've drawn that line over here, you can forget about it. You're going to be wrong. Because now you'll see what they want you to do is you just need to tell them how high you are above that. They want to know how high are you above the 1013 pressure line. Because this is the line, if you want to call it that, the line, according to which the aeroplane has been tested and according to which the performance of the aeroplane can be expressed. Okay, so we need to determine how high are we above this line. So how do we do that? Well, we know that we have 2 pressure lines over here. And we know that for 1 hectopascal, it is equal, if we decrease temperature by 1 hectopascal, it's equal to 27.7 foot. Now for PPL level, please round that up to 30 foot. CPL, ATP, make sure you stick to 27.7 foot. Okay, PPL can use 30 foot. So if we know the amount of hectopascals that we're reducing our pressure with, then we can go and determine how many feet that's going to be. So we can see over here, 1030 minus 1013 is equal to, and this is also something I want to talk about, is this thing. Guys, make sure you have a calculator with you that's working, that it's got batteries that's going to last your exam. And remember that when you are in the exam, Your mind is in a completely different dimension. You're stressed, the adrenaline's pumping, you're focused, you forget about everything around you, and you'll be surprised how quickly 4 times 3, which should be 12, turns into 16 or into 9. Okay, it happens like this. I've seen it multiple times. So I'm a big fan of, even for the most basic calculations, I still use this, right? Even something like 1030 minus 1013. Okay, it happens like this, that you make a mistake and think it is 27 instead of just 17. It happens really quickly. And if you make that mistake, your whole calculation is going to be wrong. Now you might pick this up because you don't get an answer that is close to one of the options. Then you have to redo the whole thing, guys. You have to redo all of this. So just work slowly and systematically and have structure in what you're doing, and think and take it slowly, right? Use your calculator, even for the simple things. It's not a race, it's a marathon, right? Take it slowly, do things properly. Right, so 17 hectopascals. Now we know the difference. So now we go 17 times 30 hectopascals, because we know 1 hectopascal is 30 foot. So that's going to be equal to, once again, calculator, 510 foot, right? So this distance over here, write it in, is 510 foot. So we know how high this is, we want that, and we know how high that is. Okay, so if we can take that and we subtract this, then we're going to get that. Okay, if that makes sense. So now we'll just go 2,500 foot minus 510 foot. And the reason why I want to subtract is you just want that distance, right? So see, this is where most of the students make the mistake. When you're not drawing a picture, you might have added this to your elevation, which is completely wrong. Okay, you must subtract it. So draw the picture with a pressure line over there, guys. Okay, so this is, once again, calculator. I know it's most probably 1990, but let me just check. 1990. 1990 feet. So this is the pressure altitude, 1,990 feet. Okay, now what does this mean? Let's go to the overview and understanding what we've just got. Because wow, okay, we could draw a picture, we did all the calculations, everything is good, but what does this actually mean? Well, because we have such a high pressure at sea level, even though we are 2,500 foot above sea level, so our elevation is 2,500 foot, even though we are so high above sea level, because we have such a high pressure, the aeroplane would perform not as if it's flying from 2,500 foot, but actually as if it's flying from 1,990 foot. So we'll have good performance, right? Or better performance. So instead of flying from here, we are still really flying from there, but the aeroplane would perform as if it's flying, let's take it from sea level somewhere over here, right? And that is effectively what we've calculated here. We've calculated 1,990 foot above the 1013 pressure line. That's all we've done. So the aeroplane's performance is going to be such that as if it's flying from 1,990 foot above sea level. That's what it's telling us. So good performance. Why good performance? Because we have a high pressure at sea level. High pressure at sea level means more dense air. More dense air means better thrust, means better lift, better aircraft performance. Okay? This is the one example that you can get in the exam. I see this video is becoming long, so I'm going to go a little bit faster. And you can see how crucial it is to draw a picture and to also make sure that you draw your 1013 line, either above or below the sea level line. Okay, so I'm going to change this as well. Let's make this. So there you can see we've had a high pressure. Now I'm going to change this to 1005, for instance. Okay, once again, guys, so you get a question. Aerodrome elevation 2,500 foot. QNH 1005, what is the pressure altitude? Step number 1, you should have written this down, is draw a picture. I'm going to draw a really quick picture here. That's step number 1, right? What is our elevation? 2,500 foot. Now, step number 2 is we add in all the stuff we have. 1005 hectopascals. Okay, for QNH, that's our pressure at sea level. So that is this pressure line over here. Now we need to go and determine where's the 1013 line. Okay. By now you must understand that if we go higher, the pressure is just going to start falling below this. It's going to be 1004, 1003, so we're never going to get to 1013. Now I know it's difficult to understand this concept, but you can actually go below sea level. The 1013 line is actually sitting over here, somewhere below 1005. Okay? So what are they asking us? They want the pressure altitude. So they just want the altitude from there. Okay? That's what they want, guys. It's as easy as that. So once again, can you see that now the altitude that we're going to get is going to be more than 2,500 foot, right? This is a longer line. We're flying as if we're flying from here, not from here, right? Cool. So we need to go and determine this distance, obviously. Okay, and then we're going to take this distance and we're going to add it to this distance over here, and then we'll get that distance. Okay, so let's go and determine. So it's 1013 minus 1005, that is equal to, should be 8. Don't want to be making mistakes here now. So that's 8 hectopascals, and then 8 times 30 feet. Once again, CPL ATP 27.7. Okay, this is 240 feet. Let me just make sure. Yep, 240. So this is 240 feet. Okay. Now, the important thing over here is to understand that you now need to add 240 to 2,500 foot, because we're effectively flying from here. Okay. So now we go 25 plus 240, and that is equal to 2740. So let's look at the overview and understand what has happened here. Because we have such a low pressure at sea level, you can see that our pressure at sea level is 1005, so it's a low pressure, which means obviously aircraft performance is not as good. Low pressure at sea level, although we are just 2,500 foot above sea level, with the airplane sitting over there wanting to take off, although we're just 2,500 foot above sea level, the aeroplane's performance is going to be such as if we're flying from 2,740 foot because of this low pressure at sea level. Okay, so instead of flying from this altitude, we effectively actually flying from somewhere over here, which is 2,740 foot. Now that is crucially important to understand, okay, because if you load it heavily, there's no wind, runway is uphill, it's a hot day outside, guys, you set up for failure. Not necessarily with this example, but I'm saying that if you take these conditions to the extremes, then you're going to have a tough time to become airborne. So clearly you can see now what the effect is of pressure altitude. So there's two things that's important here. I want to finish this video up. One thing is you need to understand what this number means. Okay, that is how you apply theory in flying. You need to understand what this means. You need to be careful, okay, because you're flying from 2,500 foot, but the aeroplane is not going to perform as if it is taking off from 2,500 foot. So just keep that in mind. Go to the pilot's operating handbook or the aircraft flight manual, go to your different graphs, go and calculate, right, what distance you need to get airborne, and leave a margin, okay, leave 30 or 40% margin, meaning there must be 30 or 40% left of the runway, okay, and that is the one thing. The second thing is you need to understand how to do this for the exams, okay. So I've shown you my picture, I've shown you my way of doing things. You can see it systematically. Draw the picture, put in what you've got, think about it, draw the line, calculate the difference in hectopascal, and then once again think, do I have to add or do I have to subtract? And you can just look at where the line is to determine you have to add or subtract. Okay, it's as easy as that, guys. So like I've said to you, this is 3 marks in the exam. There's no reason why you can't get this right. It's not rocket science. You need to understand pressure and temperature. You need to know what ISA is, okay, because you can see we use that with the 1013 line. And you need to be able to draw a basic picture. You don't have to be an artist. You can just draw a basic picture. Okay, so guys, thanks a lot for watching. That's it from my side. Please, if you like this video, hit the like button, follow my YouTube channel. If you've liked this video, you're most probably going to like the other videos that I'm planning on bringing out as well. On Mondays, I'll be doing mindset training, so how you can focus on studying and study schedule and how to be in the right mindset. Thursdays, I'll be bringing out, this one is late now, it's Friday already, but I'll bring out videos on Thursday. So I'll bring out content videos where we discuss certain content. So please comment below, tell me what you thought of this video, and also comment and tell me what other things you would like me to talk about, certain things that you're struggling with maybe in your subjects. Tell me what those are so that I can make a video and see how I can help you guys. The next one that I'm going to do after this one is going to be density altitude. Okay, so we've covered the basics of pressure altitude. I'll be doing density altitude. Also, give us a follow on ExamRevolution Community on our Facebook group. Okay, it's free and open to everybody. I'll be posting these videos in there as well weekly. We're giving away tips and tricks for the exams. We celebrate when students are passing. So, you know, it's a nice and motivated vibe in there. And, you know, we need to keep each other motivated and help each other, guys. That is how we progress, right? We're all there to hold hands and help each other. And so hit the like button, subscribe, and join the ExamRevolution community, and then give me your feedback. Give me your comments on what you thought of about this video. Tell me what you would like me to talk about, what other things you would like me to talk about. And then also, if you need help with your PPL online, if you need help with your PPL subjects, we've got a complete online ground school. If you thought this training is of high standard, I can guarantee you we're going to blow your mind when you look at our online training ground school. Okay, the CPL ground school is coming soon. We're really pushing hard with that. Hopefully, within the next few weeks we'll be ready with that. And yeah, so thanks a lot for watching, guys. I hope you enjoyed this video, and give me a follow and send me your feedback. I personally go through the comments, right? So I'll go and look at them personally, and I won't necessarily respond to them all, but give me your feedback, and then I look forward to seeing you guys in the next video. Thanks.